Section 1, Lesson 3, Collinearity, Betweenness, and Assumptions. Objectives of this lesson are being able to recognize points and non-collinear points, recognize when a point can be said to be between two others, recognize that each side of the triangle is shorter than the sum of the two other sides, and correctly interpret geometric diagrams. Collinearity. The definition of collinearity are points that lie on the same line. Points that do not lie on the same line are called non-collinear. So A, B, and C, because they lie on line AC, are collinear. And E, D, and F are non-collinear. In this diagram, R, S, and T are collinear points because they're on line RT. P, O, and X are also collinear, as you can see. M, O, and X are non-collinear because they're not on the same line. In order for us to say that a point is between two other points, all three of the points must be collinear. So T is between A and R in this diagram. However, we cannot say that O is between X and Y because they are not on the same line. Triangle inequality. For any 3 points, there are only 2 possibilities. One possibility is that they're collinear, which means that one point is between the other two. And the second option is that they're non-collinear, which means that the 3 points form a triangle. As you can see, triangle ABC and line AC. Line AC, A, B, and C are collinear. However, point A, point B, and point C are non-collinear, so they form a triangle. Notice that in the triangle, 11 plus 14 is less than 24. 11 and 14 are greater than 24. This is an example of the important characteristic of triangles. The sum lengths of two sides of a triangle are always greater than the length of the third. This is why 24 plus 14 is greater than 11, and 24 plus 11 are greater than 14. This makes it a triangle. In order to interpret a diagram, you should assume that straight lines and angles, the collinearity of points, the betweenness of points, and the relative positions of points. You should not assume right angles, congruent segments, congruent angles, and the relative sides of segments and angles. For example, look at this diagram shown. We can assume that ACD is a straight line, BA is a straight line, BCE is a straight line, and DE is a straight line. We can also assume that BCE is a straight angle, and C, D, and E are non-collinear. However, we cannot assume that angle BAC is a right angle, and we cannot assume that CD is congruent to DE. Line CE we cannot assume that it's congruent to line DE. And we also cannot assume that angle B is congruent to angle E. I would recommend rereading and studying the chart in the example carefully because it is important for the rest of this book. For each diagram, tell whether X is between P and R. As you can see in diagram A, X is between P and R because they are collinear. However, in diagram B, X is not in between P and R because X, P, and R are not non-collinear. Also in diagram C, you can see that X is not between P and R because they are non-collinear. Question 12. If AB equals 16, BC equals 8, and AC equals 24, which point is between the other two? So we can have line AC, which equals 24, line AB, which equals 16. So here, follow my mouse. Line AC is the entire line. It spans across 24 units. Line AB goes from here, point A, to point B, which is in the center, is 16. A to B is 16. Then B to C, which spans across the other half of line AC, equals 8. 16 plus 8 equals 24, so we can conclude that point B is in between point A and point C.
Section 1.4. In this section, we will use two-column proofs to prove theorems. Theorems are mathematical statements that can be proved. Theorem 1 says if two angles are right angles, then they are congruent. We are given that angle A is a right angle and angle B is a right angle, and we need to prove that they are both congruent. Since angle A is a right angle, it's equal to 90 degrees. And since angle B is a right angle, it's equal to 90 degrees. Since both angles are equal to 90 degrees, that means angle A is congruent to angle B. Theorem 2 says, if two angles are straight angles, then they are congruent. Since angle ABC is a straight angle and angle DEF is a straight angle, we need to prove that they are both congruent. Since angle ABC is equal to 180 degrees and angle DEF is equal to 180 degrees, they're congruent. Problem 1 says angle A is a right angle, angle C is a right angle. We need to prove that they're congruent. We do this by using the theorem 1, which is if two angles are right angles, then they're congruent. Since they are both right angles, that means they're congruent. Problem 2 says we are given the diagram shown, and we need to prove that angle EFG is equal to angle HFJ. We use theorem 2, which is if two angles are straight angles, then they are congruent. Since both of the angles are straight angles, that means they're congruent.